In this problem, I'm being given three functions, the graphs of three functions. And I have to answer where does it appear to be differentiable? Where does it appear to be continuous but not differentiable? And C, neither continuous nor differentiable. So let's take a look at the first one. And I'm given this function, this y equals f of x. It's just a squiggly function that they made up. And and this is over the interval -2 to 3. So I have -2 right here, and you can see it's a solid dot right there, so it's included. And I have 3 right here, which is also a solid dot, so that's included. So that is my interval, which I could have also written -2, 3 in brackets like that. Now, in order for something to be differentiable, the limit as x approaches a of this expression, f of x minus f of a, divided by x minus a, must exist. So you probably recognize this as one of the forms that we've used to calculate the differential, the derivative, the slope of the tangent at a particular point. It's the same, essentially the same limit as the limit as h approaches 0 of x plus h, f of x plus h minus f of x divided by h. Just a different form, a different way of putting it. But one thing you do want to remember is that in order for a limit to exist, the right-hand limit and the left-hand limit have to be the same, with the exception of an endpoint, which only will have either a right-hand or a left-hand limit. The other thing that I'd like to point out is that in order for this limit here to exist, I have to have an f of a. I have to have a value at that point that I'm looking for. The other thing that I'm going to call your attention to is this list of 7 items when a function is not differentiable. So this is in the slides. You can print it out as a separate sheet. So if there is a hole in a graph, there can't be a derivative there, because if there's no f of a, then there can't be a derivative of something that doesn't exist. In fact, there can be no derivative of any type if there's any kind of discontinuity in the function. So where there's a point of discontinuity, cannot have a derivative. If I have an open-end point, it's not differentiable. Again, there is no f of a. If I have a closed-end point, though, that can be differentiable. Not necessarily, but it can be differentiable. So, this is an important point, and this is what most people remember. If a function is differentiable, it is continuous. So wherever I have a function that is differentiable, that function is continuous. No gaps, no points of discontinuity. But just because it is continuous does not mean that it is differentiable. For example, where I have a corner or a cusp, no derivative there. The left-hand derivative and the right-hand derivative are different, so it's not a full limit. So another way to say 1 and 2 is that if a function is not continuous, therefore it is not differentiable. Okay, so let's go back to our problems. Problem number 1. This graph is smooth and continuous, no gaps, no points of discontinuity, closed endpoints. I would say that this function is differentiable over the entire domain of -2 to 3. There are no points where it is continuous but not differentiable. It's differentiable everywhere. And there are no points where it is neither continuous nor differentiable. That is a gap, a point of discontinuity. On number 8 here, well, I have a different kind of a graph. So at my endpoint over here on the left, it's a closed endpoint, so it's differentiable there. And it's certainly differentiable all along this part right here until I get to this corner. So a corner, the derivative of the left side and the right side are going to be different. So it is not differentiable, so I'm going to put not differentiable at x equals -1. After that, it's differentiable all the way until I get up here to x equals 0, where I have an open end point there, an open point there, and a closed point there. I have a jump discontinuity. So it's not differentiable at 0. But once I get past 0, it's differentiable, 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 differentiable. And then I hit this open hole in the graph right there. Now, it happens to be a removable discontinuity. And there is a point right there, but a removable discontinuity is still a discontinuity. So it is not differentiable at that point. So it is not differentiable at 2. And then I can take it all the way down here to 3, where I have a closed endpoint. It is differentiable there. So if I'm describing where it is differentiable, I'm going to say it is differentiable from -2 all the way to -1, but -1 is not included, it's not differentiable there. And then I'm uniting that with -1 all the way to 0, but again at 0 it's not differentiable. And then I'm uniting that with 0 to 2, where it is not differentiable. And then I'm uniting that with 2 to 3, and it is differentiable at 3. So that is how I would write this answer to A in interval notation. And if I was answering, so let's write here, that is A. And if I was answering B, where is it continuous but not differentiable? Well, it's continuous right there. I'm going to make it a different color. It's continuous right there, so it's continuous at -1, but it's not differentiable. But I think that's the only place where it is continuous but not differentiable. It is not continuous here at x equals 0. It is not continuous here at x equals 2. So that would be my answer to B. And then my answer to C is neither continuous nor differentiable. Well, that would be at x equals 0, because it's not continuous at x equals 0. And it is not continuous at x equals 2. So it is neither continuous nor differentiable at those points. Moving on to the next problem here. Well, again, I'm going to start from left to right. I have a closed endpoint. Well, first of all, my domain is -3 to 3, inclusive. Both are closed endpoints. So it is differentiable all along here from 3 till I get to x equals -2. And right there, I have a corner. Actually, it might be even a cusp, but there's not that much difference. It's a sharp edge, which we can't differentiate. And then it looks like it's differentiable all along here. This is a nice curve, parabola shape kind of thing. And then over here at +2, that was -2. +2, it's not differentiable. And then because I got another cusp, and then it is differentiable all the way to 3. So where does it appear to be differentiable? It appears to be differentiable from -3 to -2, not including -2. And then it continues to be differentiable from -2 to +2, but not including +2. And then it appears to be differentiable from 2 to 3, but including 3. Where is it continuous but not differentiable? Well, I think both the spots right here where it is not differentiable, it is definitely continuous. I don't have to lift my pencil off the paper to continue the graph. And I don't see any place where it is neither continuous nor differentiable. I don't see any points of discontinuity in this graph at all.